All right, welcome to chapter 7.1. Here we study solving systems of equations, and more particularly, using the substitution technique. So, systems of equations. Up to this point, most problems have involved either a function of one variable or a single equation in two variables. However, many problems in science, business, and engineering involve two or more equations in two or more variables. When two or more equations are related, it is known as a system of equations. Now, you guys have probably seen systems of equations before. Here would be an example. I have x minus y is equal to negative 4, and x plus 2y is equal to 5. Notice that this system has two equations and two unknown variables, x and y. Now, if you were to take each one of these equations individually and graph them, you would have two lines. Here I have the line x plus 2y is equal to 5 in red, and here I have x minus 4 is equal to negative 4 in blue. The solution to this system is an ordered pair that satisfies each equation in the system. In other words, that means that the solutions to a system of equations are the points of intersection of our curves, or in this case, of our two lines. So where do these two lines intersect? They intersect at negative 1, comma 3. That is the solution to this system of equations. So note that the solution, negative 1, 3, makes both of the equations in the system true. This is very, very important. If we were to plug in negative 1 for x and 3 for y, we would get out negative 4. If we plug in negative 1 for x here and 3 for y, we get out 5. It makes both equations true. It is the solution that satisfies both equations in our system. So that's how we find them graphically. Now let's talk about the substitution technique that's going to allow us to solve systems of equations. You guys have probably done substitution before, but if not, no worries. Take a look. Here are our steps for the method of substitution. Number 1, solve one equation for one variable in terms of the other. Pick the easiest one. Substitute the expression found in step 1 into the other equation to obtain an equation in one variable. 3. Solve the equation obtained in step 2. 4. Back substitute the value obtained in step 3 into the expression obtained in step 1 to find the value of the other variable. And finally, check that the solution satisfies each of the original equations. Plug in your answer and make sure it works out. Let's take a look at a few examples here. Solve the system using substitution. Well, first thing we need to do is isolate a variable in one equation. And again, you can pick whichever variable you would like. In this case, we're going to isolate y in the first equation. Well, to isolate y in the first equation, I would subtract x. That tells me that y is equal to 4 minus x. I can now substitute that into my second equation for y. So I'm going to replace y with this entire quantity 4 minus x. That gives me x minus 4 minus x is equal to 2. And notice that gives me an equation now that only has one variable. And I can use my normal algebra to begin to solve. In distributing the negative, notice I have a x minus a negative x. That's going to be adding an x. That gives me 2x minus 4 is equal to 2. Okay. We can group all our constants on one side by adding 4. 2x is equal to 6, and x is equal to 3. Once we have solved for one variable, we are going to back substitute that into our equation up here that we generated where we have y isolated. We can back substitute it into this equation to solve for y. Now, technically, you could back substitute it into either of these original equations, but it's much easier to use this manipulated equation because it already tells us what y is equal to. So back substituting into our equation for y, we get y is equal to 4 minus 3. Y is equal to 1. And we want to write our answer as an ordered pair. Our final solution is going to be 3, 1. We can check our answer by plugging the ordered pair into each of the original equations. So if I plug in 3 for x and 1 for y, 3 plus 1 equals 4. Checks out. 3 minus 1 is equal to 2. That also gives me a true statement. If it makes both of those equations true, then that is your solution. We could also check our answer graphically by graphing each one of these equations and finding their intersection point. All right, here I have the graph of each one of these lines. We graph them, and we do recognize they intersect at 3, comma 1. All right, so two different ways to verify your answer. Let's try another one here. Solve the system using substitution. Again, we want to begin by isolating a variable. Pick the easiest one. Well, what's the easiest variable to isolate in this system? That's definitely going to be x. If we isolate x in the first equation, we get x is equal to 2y. We can now substitute that quantity in for x into our second equation. That gives us 3 times 2y minus y squared is equal to 0, or 6y minus y squared is equal to 0. Notice that the resulting equation is a quadratic. And how do we solve quadratics? Well, we set them equal to 0 and we factor. In this case, we're already set equal to 0. We can pull out our greatest common factor of y. All right, pulling out a common factor of y, we get y times 6 minus y is equal to 0. Setting each one of those factors equal to 0 and solving gives us y is equal to 0 and y is equal to 6. So notice in this case that we end up with two values for y. That is okay. What does that mean? Well, that just means we're going to have two different corresponding x values as well. So how are we going to solve for x? Well, we can back substitute it into this equation right here, which tells us what x is equal to. X is equal to 2y. Well, if x is equal to 2y, x is equal to 2 times 0. 2 times 0 is 0, giving us x equals 0. We can also plug in 6 for y. X is equal to 2 times 6, leaving us with x is equal to 12. So in this case, we have two separate solutions. And again, be sure to write your answers as ordered pairs so that you are staying organized and you understand which values are going together. All right, our ordered pairs are going to be 0, 0, and 12, comma 6, right? The zeros pair together and the 12 and the 6 pair together. Those are our two solutions. And we can verify both of those solutions by plugging the ordered pairs into each of the original equations. And if we plug those values in for x and y, it will make each one of those original equations true. Similarly, if we were to look at this graphically, right, here are the graphs of our two different curves. In this case, I have a sideways parabola and a line. And notice their points of intersection. Where do they intersect? 0, 0, and 12, comma 6. Those are our solutions. All right, so there you have it, a basic introduction to solving systems of equations using the method of substitution, and also how to verify your work graphically.